In this video, we're going to look at analyzing poll results. So a pollster sampled n equals 1,182 people and found that 662 of the voters sampled were in favor of candidate A. Okay, and let's do a different color for the next candidate. And 520 of the voters sampled were in favor of candidate B. Okay, we're going to answer the questions below and round any percents to 1 decimal place as needed. Okay, so notice in this example we weren't given the sample percentages, okay, or the sample proportions. We were just given the counts. But it's easy to find the sample proportions. For candidate A, they had 662 out of the 1,182 votes. We want to write that as a percentage, so we'll multiply by 100%. So 662 divided by 1182 times 100. So candidate A has 56%, not exactly, but that's what we'd round to 1 decimal place. Now let's look at candidate B. Well, candidate B had 520 votes out of 1,182. Okay, and assuming that everybody favored either candidate A or B, which is all we've been looking at, this should be 44%, but we'll just compute it anyway. So 520 divided by 1182 times 100%. And rounded to 1 decimal place, this rounds up to the whole number of 44%. Okay, so now we have our sample proportions for each candidate. Let's find the margin of error. So that's 1 over the square root of the sample size, 1,182, and we're going to multiply that by 100%. So first, we'll put in 1182, find its square root, invert it, and multiply by 100. And to 1 decimal place, that's 2.9%. Now, using these values, we're going to find some confidence intervals and make some conclusions. So we're asked to find the 95% confidence interval for candidate A. Okay, I'm going to write some spots. Notice I put all of our values up here. So candidate A's votes lie between blank and blank. Okay, and let me use this for computing space. Okay, so we have 56%. We want to subtract the margin of error, 2.9 for the lower value, and add the margin of error for the upper value. Now let's do these in our head and you can check them on the calculator. So adding 2.9 is 58.9%. 56, if we subtract 3, that would be 53, so it'll be 53.1%. Okay, so that means candidate A's, let's put this in candidate A's colors. We are 95% confident that the true value of the percent of candidate A's votes lie between 53.1% and 58.9%. Okay. Next, we are 95% confident that the true value of the percent of candidate B's votes lie between. So let's get this ready. We're going to put our values over here. And candidate B, we'll do this part in blue for candidate B. P hat is 44%. So if we subtract 2.9 from 44, that's 41.1%. And if we add 2.9% to 44%, that's 46.9%. So we are 95% confident that the true value of percent of candidate B's votes lies between 41.1%, and 46.9%. Okay. Next, we're asked, do the 95% confidence intervals for candidate A and candidate B overlap? And they actually do not. Let's draw a picture. Okay, so I'm making a number line. Candidate B, we'll use blue. I'm going to say this is 43.1 and this is 58.9. Okay, that was candidate A. And candidate B, its upper value is 46.9, so it's a little bit to the left, and its lower value is 41.1. Okay, so since these confidence intervals don't overlap, okay, it appears that there's statistical evidence that this candidate, which is candidate A, is in fact in the lead. Okay, so we saw that they are 12 percentage points higher than candidate B, and with a margin of error of 3%, it looks like they are in fact in the lead. So, based on our previous answer, we would choose option 1. There is statistical evidence that candidate A is in the lead.